Hello and welcome to this video where we're going to be looking at the equations of motion, which is in the subtopic of 3.1 motion in the module 3 forces of motion for OCR A-Level Physics. So if we've been successful and we've learned in today's lesson, we should understand the different measurable terms for an object undergoing motion, calculate the displacement of an object moving with uniform acceleration, and explain what else we need to know to calculate the acceleration of an object if we know its displacement in a given time. So in today's lesson we're going to be looking at the following parts of the OCR A-Level Physics specification, in particular 3.1.2 linear motion, which is the equations of motion for a constant acceleration in a straight line, including the motion of falling objects in a uniform gravitational field without air resistance. So the following quantities can be measured to determine the motion of an object mathematically. The first one is displacement, which is given the symbol s, which is how far an object travels from its starting point in a given direction. We then have the starting velocity, which is symbolized with u, which is the rate of change of an object's displacement at the start of the journey. We have the final velocity, symbolized with v, which is the rate of change of an object's displacement at the end of the journey. We have the acceleration, symbolized with a, which is the rate of change of an object's velocity. And then we have time taken, symbolized with t. So this is the time in which the object is in motion. So we have displacement, initial velocity, final velocity, acceleration in time, s, u, v, a, and t. Now we can place these different measurable factors into different equations to fully describe the motion of an object. Now we call these equations the equations of motion or the SUVAT equations. So the SUVAT equations can be used to work out values of an object moving when the object is moving with constant acceleration. Now constant acceleration can also be called uniform acceleration, and these equations involve the motion in a straight line at a constant acceleration. Now an object will achieve constant acceleration when it has a constant resultant force acting upon it. Now the most common example of constant acceleration is when an object is falling freely under gravity. Now near the Earth's surface, any object falling freely under gravity has an acceleration of about 9.81 meters per second squared. Now other possible examples of uniform acceleration could be a plane taking off, or a train pulling out of a station, or a car on a motorway. Now we call these equations the equations of motion or SUVAT due to the possible terms that can be found in the equation s, u, v, a, and t. Now please do remember that s here stands for displacement, not speed, whilst if we did have d it will be for distance travelled. Now again also remember that u and v in the SUVAT equations are instantaneous velocities, the initial starting velocity and the final velocity, not average values. Now we can derive the equations of motion from displacement time and velocity time graphs. So consider a velocity time graph for an object undergoing constant acceleration. Now the graph here represents the motion of the object. Its initial velocity is u, and after time t its final velocity is v. Now as we know, the graph is a straight line because the object's acceleration is constant, and the gradient of the slope, so the gradient of the line, which is the slope, is equal to the acceleration. So we can define from this one the acceleration is the change in velocity over the change in time, or the change in y over the change in x. So a is equal to v minus u, the change in velocity, over t. So rearranging this equation gives us the first equation of motion, v equals u plus at. Now, displacement is then given by the area under the velocity time graph. So this shows that the object's average velocity is halfway between u and v as it's undergoing constant acceleration. So the object's average velocity can be calculated by averaging its initial and final velocities, given by the equation u plus v minus divided by 2, because we're going to work out our average velocity. So the object's displacement is in our shaded area. So this is the rectangle, and so we have the equation that displacement is equal to average velocity times by time taken. So it's u plus v over 2 times by t. Now from equations 1 and 2 we can derive equation 3. So if we say v equals u plus at and s equals u plus v divided by 2 times by t, we can substitute v from equation 1 into equation 2 to give us the idea that s equals u plus at over 2 times by t. So s equals 2ut over 2 plus at squared over 2. So we can therefore simplify that to give our third equation, which is s equals ut plus a half at squared. Now from equations 1 and 2 we can then derive equation 4. So again we have v equals u plus at and s equals u plus v over 2 times by t. We can substitute for t from the first equation, so we can say s equals u plus v over 2 plus v plus u over a, so therefore 2as equals u plus v times by v minus u, which we can then factorize to say 2as equals v squared minus u squared. So this can be rearranged to give our final equation of motion, v squared equals u squared plus 2as. So the equations of motion are v equals u plus at, s equals u plus v over 2 times by t, s equals ut plus a half at squared, and v squared equals u squared plus 2as. Now any question can be solved if three of the variables are given in the question. So in a question with the equations of motion, you would write down all the variables you have and the one you were asked to find, and then see what equation you can use. Now remember, these equations can only be used for motion with uniform acceleration. So to answer equations of motion questions correctly, follow these steps. The first step is to write out the variables which are known in the question. Then use this to select the correct motion equation. There should only be one unknown variable in the equation chosen. In addition, try to pick an equation that doesn't rely on any previously calculated values you've carried out in parts of the question. Then place the numbers into the equation. Remember to ensure the units are in the correct form. Then simplify and rearrange the equation as needed. Then calculate an answer and place that in the correct units with the correct significant figures. And then finally remember our assumption that this can only occur when the acceleration is constant with a non-zero velocity. So here's an example calculation. A student investigates terminal velocity by dropping balls of modelling clay in liquid. For a particular ball, she makes the following measurements. Initial velocity is 0.035 meters per second, final velocity is 0.013 meters per second, and the distance with which velocity changes is 0.30 meters. What is the average acceleration of the ball during this journey? So the first step is to write out the variables which are known in the question. The second step is then to select the correct motion equation, and there should only be one unknown variable in the equation chosen. So we're choosing v squared minus u squared equals 2as. We can then, for the third step, place the numbers into the equation. Remember to ensure the units are in the correct form. We then simplify and rearrange the equation as needed, as shown below. We can then calculate an answer and then place the answer with the correct units and the correct number of significant figures. So this answer works out to be minus 0.20 meters per second squared. Now remember, a negative acceleration means that our object is decelerating or slowing down. So let's have a look at another example calculation. A driver of a vehicle travelling at a speed of 30 meters per second on a motorway brakes sharply to a standstill in a distance of 100 meters. Calculate the deceleration of the vehicle. So the first step is to write out the variables s, u, v, a, and t, which are known in the question. The second step is to select the correct motion equation, where again there should be only one unknown variable in the equation chosen. You would then place in the numbers into the equation, remember to ensure the units are in the correct form. So you would simplify and rearrange the equation as needed, as shown on the screen here. And then you would place an answer with the correct units and the correct significant figures. So acceleration here is minus 4.5 meters per second squared, which indicates that the negative value shows that the object is accelerating in the opposite direction to the velocity. So just a few tips on how to identify values in SUVAT questions. If in the question it says to you, the object returns to its starting position, that's a way of saying our displacement s is equal to 0. If the question says the object is initially at rest or stationary, that's ways of saying that the initial velocity u is equal to 0. And if it says comes to rest, that's a way of saying that v, the final velocity, is equal to 0. And then finally, if the question says to you falls freely, that's a way of saying acceleration is equal to gravity, which in this case is 9.81 if it is on the Earth. So that brings an end to our lesson on equations of motion today. If we've been successful, we should be able to understand the different terms in the SUVAT equations S, U, V, A and T. We should be able to calculate values of S, U, V, A and T using our equations of motion, and then link the different equations of motion together and understand how they are derived. So thank you so much for watching this lesson on the equations of motion, which is part of the motion subtopic in the module Forces of Motion for OCR A-Level Physics. Thank you so much for watching and have a lovely day.